amount of days spent in a hospital has been reduced drastically by companies like Alpinestars. I've crashed in this modern race equipment, and your pain and suffering is so much more limited by the things they do. The impact absorbent armor, the plastic they've used, the venting, the mesh in certain places, the leather here, all the things they put together. It's a science now to protect you.
To maximize protection, each leather racing suit is custom fit and handcrafted for individual racers.
This is our leather suit development process, and here on screen we're looking at a design we've done for Troy Corser, the world superbike rider with the Yamaha team. From the graphic design on the computer screen, we now move to full-size panel drawings, where we are now creating the actual panels that we use to cut out the leather suit.
The computer prints out a complete diagram of each piece for each suit. The paper parts are then cut out by hand and transferred to stiff cardboard, which becomes the actual templates for cutting out the leather.
Key to this is the hand skill involved in selecting particular parts of the hide to produce complementary parts of the suit, so that the suit ends up looking balanced and features the best possible safety performance across each part of the suit. One of the skills in doing this job is to make the most of the entire hide.
It's a combination of old-world hand-done craftsmanship with leading-edge science backed by years of research into what hurts us when we crash.
Once all the parts are cut and ready, they're delivered to the workshop, a large room where dozens of people will each play a part in creating one more perfect riding suit.
In the actual production facility, we're looking at the final process where we brought together all the component parts of the leather suit, and they start at one end of the line, and over about a 2-day period we're in a great deal of handwork, detailed stitching, both of panels, of stretch panels, of logos, and the safety equipment that we build into the suit.
Walking in the Alpinestars factory, for instance, you'll see a bunch of Italian women sewing things together by hand, and you'll think to yourself, oh, here's an old world leather shop where they're making shoes, you know, from hundreds of years ago. But what you're really seeing is women fashioning together a leading-edge, scientifically derived equipment that protects a motorcycle racer when things go wrong.
And this is the final result. This is one of Troy Corser's finished suits, ready for him to go racing. And all of those components that we've already looked at, from the external shoulder protection, stretch panels, and the actual hand-cut leather panels, which have all been perforated, is finally put together in a finished suit that should fit him perfectly when he goes out on the racetrack.
One of the secrets to modern motorcycle riding gear is that it's designed to alter time, to extend the split second of impact for as long as possible. The padded hump on the back of the leather suit is the key to scientifically measuring the forces involved when riding, racing, and accidents when they happen.
Originally this was put here for more an aerodynamic reason, but additionally, should the rider fall backwards onto his back and hit his head against the ground, it does also provide a little bit of support between the head and the body to prevent an extreme bend of the neck. However, the beauty of having this hump means we can fill it with all sorts of exciting equipment, which helps us find out a bit more about the leather suit.
That equipment is a data logging system that includes a GPS satellite unit an inertial motion sensor, and a computer processor powerful enough to monitor and record up to 130 different sensor inputs at a rate of 1,000 times a second.
We can fit out the suit with any sensor you can think of, be it pressure sensors to identify pressure points in the suit, temperature and humidity sensors to measure the comfort in the suit, and even things like a heartbeat monitor.
One of the most amazing things the sensors reveal is that during a race, the rider's body will move through an arc of 140 degrees as they swing from one side of the bike to the other. Using the GPS unit, the sensors can also follow a rider around the track, measuring G-forces on his body as the bike brakes or accelerates. But the most important measurements are what happens should the rider crash.
With the inertial motion unit, we're primarily measuring the orientation of the rider's body, and then whenever the rider's body is subject to any force, such as an impact, we can work out the magnitude or how large that impact actually was.
That impact can be as high as 5 times the force of gravity.
Example of the accident, if someone weighs 200 pounds, for that very split second, they're going to be experiencing perhaps 5G and weighing sort of 1,000 pounds. Obviously, that's an extreme force, but it's in a very narrow space of time, So it's a little bit like an impact, and our job is really to try and make sure that this time where the energy is transferred is really as large as possible.
They spend a tremendous amount of time in the laboratory analyzing the information from their data acquisition system. Understanding that information can help improve rider safety, but there's literally no margin for error.
Obviously, you have to be very careful when you're incorporating technology in the suit, such that we're not actually channeling the force into the body, but spreading the force.
The same premise is used to design riding boots. The idea is to control and redirect the forces of an impact.
Critically, we try to prevent the force of the impact being transmitted to other parts of the leg, so it doesn't explode your knee.
That's why boots are a critical and highly sophisticated piece of riding equipment. A lot has changed at the Alpinestars factory since the company first began making motorcycle boots in the 1960s. Today, the company's boots are as high-tech as boots can get.
And we're looking at the footbed section of the Tech 10 boot. The process actually begins with our designer doing a lot of hand drawing. Then we move into CAD images where we can manipulate the actual shape and construction. From the CAD design, we move to rapid prototyping, which allows us to very quickly make up the sections of the boot that we want to analyze. We have the solid spine, the dark blue part that was on the CAD drawing. We have the heel counter, thick thermoplastic providing good protection in the heel, and thick thermoplastic in the actual forward toe box area. And then we move to the finished article, and this is it, the actual manufactured Tech 10.
Like all Alpinestar boots, all the parts of the Tech 10 are assembled by hand. First, each piece is brushed with a special permanent adhesive, and then individual parts glued together to form sub-assemblies. Those sub-assemblies are then hammered into place. It's a tight fit, but Alpinestars prides themselves on making boots that will not fail or come apart. That would compromise the boot's protection. Each boot is placed onto what looks like an assembly line, but it's actually a machine where heat helps cure the glue. Finally, a multiple density rubber foam sole is fitted to the boot. Then it's placed in a second heating unit, which makes the bond between the boot and the sole permanent. With the boot almost finished, a grinder is used to remove any excess glue. Then a special press punches precise holes for the boot buckle. Again, the entire boot is checked and cleaned. The last step, yet one more cleaning and inspection before each boot is boxed for shipment.